So first, we'd like to welcome everybody out and thanks for joining. We're excited about our webinar today and to have one of our partners join us, Stähle Robot Systems. Our speakers today are Judd. He is the ASI Automotive Product Manager, and then we have Cedric Ossalina, and he is the Stähle Robot Systems Business Development Manager. So we'll first go through the presentation, and then we'll have time after for questions. The chat is also open for questions. So if you have any that you think of during the presentation, you can go ahead and throw them in there, and we will address them at the end. So yeah, now I'll turn it over to Jed.
Thanks everybody for joining us today. We're excited to have you, and Cedric, thanks for joining us. We really appreciate the relationship and the partnership that we have with Stähle Robots, and appreciate the great engineering that goes into those. Just a quick introduction for me, and then Cedric, I'll turn it over to you to introduce yourself and Stähle. But for ASI, we were founded in 2000 to provide autonomous solutions for the dull, dirty, and dangerous jobs that people don't like to do. We're about 180 employees right now, and for the last 22 years, we've been providing OEM agnostic vehicle automation in automotive, agriculture, mining, and military. And if any of you follow ASI, we recently sold the mining portion of the business to Epiroc. So that means that we'll be focusing more in these other areas. Areas of specialization that we focus on is the durability, misuse, and ADAS. We've got advanced perception systems, and we've worked with the military, and of course, OEM agnostic hardware. Cedric, thank you for joining us.
Yeah, so today I joined the meeting because of one product that we share with ASI Robot. We support them with our robotics. And I'm working personally for now 6 years at Stähle. Stähle is a private company. Just click. A private company in the south of Germany. In this area, we have a high density in the automotive industry. We have a lot of partners and customers around the corner. And our story began for around 40 years, where we made our first robot for a climate room at BMW, and for that point of time the company decided to orient it to automotive industry, and most of our applications are around test bench, so chassis dyno and emission cycle, durability, and we have more than 1,300 installations spread over the world. And for now, around 7 years, our company decided to expand the portfolio, looking at proving ground application, and we come with the same philosophy as we did for test bench. We try to be open, agnostic to other systems, and we are very proud to share our experience with ASI. So what we do, robots for any kind of vehicle. So we do it for two-wheelers, for three-wheelers, like in South Asia, and three-wheelers of every kind of size. For the presentation today, we are just looking at four-wheelers. And I will jump into Jed's presentation when we come to the installation of a robot for the proving ground.
Okay, well, yes, thank you for that introduction. So with ASI and Stähle offers software and hardware watchdogs. They've got a spring-loaded actuator positions, additional redundant brake systems, and ASI offers Mobius with advanced safety watchdogs again, and operating from a remote. You can operate it from a remote location. It offers teleoperation capabilities and especially multiple vehicle control. So together, ASI and Stähle provide advanced robotic solutions with ASI's comprehensive Mobius software platform. And with this, the Stähle robot will ensure consistent error-free testing execution. Mobius software provides the analytics and real-time monitoring, giving you increased data insights. We streamline the processes and reduce development time and cost to accelerate vehicle development. And the automated systems optimize operational workflow that increase efficiency. You will benefit from the solution compatible with any vehicle manufacturer, ensuring flexibility and broad application. With Mobius, it is our flagship command and control software. It expands human capabilities to commanding multiple vehicles in a user-friendly way with built-in AI to help you improve productivity and tasking vehicles. We've got real-time notifications and vehicle monitoring that helps keep your staff, facilities, and vehicles safe as you are running the tests. Together, both ASI and Stähle have automated commercial and passenger vehicles on proving grounds around the globe. From semi-trucks to trolleys, we've got you covered. Cedric, why don't you tell us a little bit more about your setup?
Yes. Well, actually, when you look at all this type of vehicle of different size, you can think how can you put a robot for every single vehicle. And what we have is one robot that you can use for all these machines without drilling or without using a tension belt. The common point you have with every vehicle so far is the seat rail. You always have a seat rail underneath your driver's seat. So basically we will use this seat rail just on a little portion, the front one, to install our seat rail adapter, which is the element you have in the middle of this slide, and we will use it as an anchor to snap one actuator after the other. So typically, to automize the vehicle, there are three components, three axes you need. You need to automize the throttle, the brake, and the steering wheel. And the few videos I have on the next slide are about a Mini made by BMW. It's a really small car. And on the video, you can see my colleague with this seat rail adapter and a wrench in his hand. So actually it just moved the driver's seat a little bit to the back so it can access to the seat rail, and then with a hook which is linked with a screw, you can tie it on both sides. So you have to tie it on one side. On the next slide you can see the second screw on. And you can also notice on the seat rail adapter that you have a lot of different holes and shapes. It's actually a really flexible system. You can adapt whatever you have for width, and then you can have access to a lot of different actuators we have in the portfolio. But here, for the sake of this video, we just take some standard element. So now you have already your anchor in system, which is already fixed, it's very sturdy, and you have a low gravity point because you're just on the floor, on the carpet of your vehicle. So then you just need to snap one actuator with the other. The first one would be the throttle actuator. So sorry for the sound, sometimes the sign is coming. It was in the factory. And as you can see on this video, you have a T shape. So you slide the actuator into it. So you adapt your height for the actuator. And then on the second step, you have a long ruler with small holes patterns. So then you can slide the actuator into the direction of the throttle, depending on how far you will have the throttle from the driver's seat. So then you see a lever. Just come back. Then you have a lever, and the lever is just lying on the pedal. Means, in other words, because of the weight of the pedal of the lever, is laying on the throttle. But afterwards, if you are as a driver into the car, as a safety driver, you can override the throttle easily because you press on the lever. Then next slide. So the second step will be to install the brake actuator. So for the brake actuator, it's another design. We have first the motor itself, where we just have to lock one screw on the C12 adapter. And then on the second step, we have a kind of fork. So the fork is a clamping system which goes behind this, the brake pedal, and then you just have a twist of rubber plastic screw that you tied against the fork which is behind the brake pedal. So you don't have any deterioration, you don't make any traces on the pedal with the system. And you see a long rod, it's a telescopic rod, you link it to the actuator, and you have a pin for this, and then you tension the hole so that it gets really stiff, so that for every single small movement of the actuator, you give it directly to the brake pedal. So from them, you have already installed two different pedals. Now on this slide, I wanted to show you one specific thing about the application with ASI Robot. There are a lot of customers which are working today with safety drivers. So what you see on the left, on the right side is what you already see in the video. It's an installation of a brake robot. But if you want to work with ASI Robot, you essentially want to work without safety driver. You want to work driverless. And what we offer is an option which is a pneumatical redundancy. In other words, you would take a tank with pressurized air into your car, and the valve which is installed on it is closed as long as it gets electricity. In other words, if the valve do not have any electricity, the valve is open and then push on the brake. So this installation makes things really secure, because all the robot is working with electricity. So if you don't have electricity, then you are sure that the car stops. And next slide. So now the third step would be the preparation for installing the steering robot. So as I said before, the C12 adapter is the anchor of the system. So what we have first is the preparation with a torque support we put on the C12 adapter that we will link to the steering robot later on. So now the steering robot, the design of itself is, I like to tell that it's a crown, because you have a big metallic ring which is toothed on the rear side, and you have three hooks. So the first step is that you bring the steering robot behind the steering wheel and then turn the hooks, and you see that there's actuator which is laying on the downside. So that means that the actuator is moving, turning on the tooth of the rear of the ring, and when you don't touch the actuator, by gravity is going down. So the first step, just hanging the robot. Then further on, what we do, we drive with a screwdriver all the hooks to the inner side. So we adapt the steering robot to the diameter of the steering wheel. So it's always with the same Allen Bradley wrench. It's always the same size. Every screw at the same size. We are just like IKEA. We do everything in same size. So here you have the three hooks. We are going tight. But this is not where we apply our forces. All the torque won't be on the hooks, but on two small branches you see on the side, and my colleague slide into it with a yellow 3D plastic nozzle. Well, actually we apply all the torque, all the forces on the side arms of the steering wheel, and because it has a kind of triangle shape, you can end up whatever thickness you will have on the steering wheel. And if you imagine the operation is, instead of scratching the outside of a steering wheel with friction, with tension belt or whatever, what we do, we apply force like 2 fingers on both sides of the steering wheel at the same moment. So now you are already centered the steering robot, you are already attached to it. You only have one step more, is deciding where to put the actuator. Because it's totally loose, you can decide wherever you want to have it. If you're a safety driver, you don't want the motor between your legs. You prefer to have it on the right side, on the left side. Doesn't make any difference. The only thing that depending on the design of the car, you have whippers, you have lights and other elements behind the steering wheel which are annoying. So we just move the actuator where you have space. And when you decide on the height where you want to have it, then you link the torque support with the actuator. And because the torque support is a bar but in 3 bodies, the idea is to orientate the bar a little bit parallel to the steering wheel, because the steering wheel is never that straight or that flat, it's something in between, and we put the bar in around in parallel so that during the operation of the steering robot the bar won't be moving. And then you're already all set. You are ready. You will have to bring electricity to the robot. You will have to teach in the pedals and to calibrate it. But then you can see that all the installation is around the driver. So you can use the driver seat, for instance, for initiating your work with ASI. Drive manually with the robot and register on the go what you have driven, and then the robot will repeat it. So we just saw videos with a Mini, which is a very small car, but with the same robot you can adapt it to a truck. So there are 2 things you need for this, to put it on a truck. You need an adapter for the steering wheel, because it may be bigger in diameter, and you need a truck seat rail adapter, because sometimes the seat rail is a little bit higher. It's put next to the seat, but underneath the driver seat you have this kind of hydraulic system, suspension system for long drive. So we need to adapt in height. So for this you don't have to invest in different robots, you just have to have 2 different adapters. So the presentation was about 3 axes. I said throttle, brake, steering. But in Europe, for instance, we have a lot of other things, funny things. When you want to have mechanical gearing, then there are different designs. It can be on the steering wheel behind it. It can be on your left or right hand. It can be push buttons, pull buttons. We have every kind of design. And because we come from chassis dyno test bench application, we are doing this for a really long time. So we have every kind of actuators for this activity. And I take the opportunity just to show you a little video showing for this Mini the flow shifter. So we use for this the passenger seat. So we put all the system on the passenger seat. There are 2 foot. And then we tension the security belt. Then we have a locker on the left, on the right side, depending if you are a right-hand drive or left-hand drive. And then you tension all the system. So this is really a sturdy system. And then you see the shift robot is put aside. On the next step, you see this is installation, we call it super seat plate. It's really sturdy. It's so sturdy that we have IMU manufacturer who use it, because you have really few movement on it. The thing is, I want to show you with this shifter, it's like a hand. You unlock it, so you move it manually into the place where you need it. You lock the hand, and then you can move the robot. Why do you need to move by hand the robot? Well, actually, it's what you will do for the teaching. It's really simple. You look for one gear, and you have a remote and say, this is first gear. You move, this is second gear, and so on and so on. And then on the soft, you will have different diagrams with different shape, and you just select the type of flow shifter you have. And then your robot will always repeat on the right position. So this is also an element you can use with our technology. And the idea of our robot is just to be you can install it on every kind of vehicle, and for some vehicle we need some specific solution, but we have it. On the other hand, it might be that you don't need any actuator because your car is using another technologies, for instance, drive-by-wire. So if you use drive-by-wire, we have a specific solution for this. You can we can provide an interface to this CAN bus signal. Or if you have to test autonomous vehicle, you don't need any robot because the vehicle will move from itself. For this, we have also an emergency brake actuator. Is actually what I show you on the brake actuator upgrade, but here is the same solution as a standalone. So you have in blue a little pressed air reservoir, and then with a valve you can press on the brake whenever you need or when you have a shortage of electricity. So now already my last slide. So just wanted to show you we work with ASI because we believe that we need to be into a control station, and they provide the system. For our side, we try to be the most versatile as possible, and the solution today was typical installation under 10 minutes. We have a teaching setup. We do not have any calibration. You install and disassemble the system without making any traces, so you can change from car really quickly. And if you need safety driver for the operation, you can be sure that the safety driver is not in a dangerous situation because everything is very sturdy, clamped, the airbag is not covered, and we do not use the windscreen, so they have totally free view.
Yeah, that's what we've loved about working with the Stähle robot, and it helps save with the track time and the setup. So you can come in, get set up, and get started testing right away. We love that we can use the Stähle teach-in option for steering, transmission, brake, throttle on your tablet, or we've created an integration with ASI's Mobius to be able to use our step-by-step calibration wizard. This gives you the flexibility of using Stähle's native software and tests and ASI's Mobius. With Mobius and driving robots, you have the flexibility of working from a command center or taking things right to the track, right on the road in a mobile command center. Either way, being able to autonomously operate vehicles or use Mobius's teleoperation capabilities to drive them using a gamepad or a steering wheel is always available. Mobius can read data that's available on the OBD or CAN bus, such as engine temperature, RPM, tire pressure, battery, charge status, and then you can set triggers in Mobius to stop the vehicle or provide a notification. For example, users can put a maximum or a minimum range on engine temperature and then have the system stop the vehicle and notify the user if the temperature goes out of range. We're always monitoring off-path error. When a configurable off-path tolerance is exceeded, the vehicle will be stopped automatically. This automated stop addresses many potential mechanical or navigational issues that may arise. We're always running system checks as well. The system is continuously checking and comparing multiple telemetry sources to confirm that everything is operating properly. For example, it's going to check the position of the transmission off of the can and compares it to the position of the transmission from the shifter robot. If the transmission starts to slip, it will show an error and stop the vehicle. It checks wheel speed against the speed calculated by calculated against the GPS internally, and if there's any wheel slip, it can stop the vehicle. There are literally hundreds of safety items it checks constantly, and if anything doesn't show correctly, it will stop the vehicle and report why it stopped the vehicle to the operator. We do recommend that when you're using robots, especially in durability settings, that you still inspect the vehicle at least once per shift. Make sure that things are still operating properly. Have eyes on the vehicle. As part of that inspection, a lot of our customers will have a safety rider. So like Cedric was saying, it's important to have space for the safety rider to be able to be in the vehicle and send a safety rider on the routes. Make sure that you still have visibility. Inspect the vehicle and the roads for any conditions that are not detectable by the robot. Driving robots can do what human drivers shouldn't do. And in addition to safety monitoring, ASI's Mobius acts as a safety rider. It's always on the lookout for obstacles and safe operation. Mobius provides safe area lockouts and geofencing, only allowing autonomous vehicles to drive where you specify. We've helped customers in durability, misuse, impact, mileage accumulation testing on things like gravel roads, unimproved roads, through mud and water, through constant speed or mileage accumulation, uneven ground, curb impacts, braking tests into potholes, twist ditches, extreme cold, hot sand, dust tests, high altitude, ADAS, swarm testing, and even SRC testing. As a review, driving robots do what human drivers shouldn't. We allow you to test your vehicles, not your drivers. The modular install with the Stähle robots takes less than 10 minutes, and when teamed with ASI's Mobius, allows you to control multiple vehicles at a time. We also offer consulting, commissioning, and training services to help you be successful. Please reach out to us for more information on our turnkey solution to help you getting running with driving robots on your proving grounds. Thank you so much for joining us today, Cedric especially for showing us your great robot. And for those of you who have joined online, please let us know if you have questions.